All right, so as promised, we are here in 13.4 and 13.6, which is food chains, food webs, and pyramid models. Again, a lot of this stuff is just review for you guys because you have seen food chains before, or you've seen food webs, maybe a few pyramids, that might be some new stuff, but for the most part, this is all review. So our key concepts. Food chains and food webs model the flow of energy in an ecosystem. Pyramids model the distribution of energy and matter in an ecosystem. Okay, our new vocabulary, we've got food chain, carnivore, detrivore, herbivore, omnivore, decomposer, specialist, generalist, trophic level, food web, energy pyramid, biomass pyramid, and pyramid of numbers. Our essential question is just how does energy move through an ecosystem? And in all honesty, that's what this focus is. It's the focus on energy. Where did the energy come from and where is the energy going? So when we talk about food chains, a food chain is a simple model that shows the sequence of a feeding relationship. Okay, so it follows the flow of energy, and the food chains link species by their feeding relationships. It follows just a single connection between one producer and a single chain of consumers within an ecosystem. So there we are, we've got our grass, which is transferring its energy to the cottontail, which is then transferring its energy to the hawk. And you can see the direction of the arrows is showing actually where the transfer of energy is going. The energy started in our grass because the grass does photosynthesis. It's giving its energy to the rabbit when the rabbit eats it. That rabbit is giving its energy to the hawk when the hawk eats it. So it's showing the flow of energy, not who eats what. That's the direction of the arrows, show where is the energy going. Now, all consumers are not alike. We have different levels of consumers. We've got herbivores, which eat only plants, and carnivores, which eat only animals. And then we have something called an omnivore. Omna means everything. It eats both plants and animals. Then we have detritivores, which eat dead organic matter. And then we have decomposers, which basically break down that matter into simpler compounds. They are detritivores, but they do break it down into much more simpler compounds. Okay, so decomposers, things like worms and bacteria would be decomposers. Okay, also fungus and mushrooms would be decomposers. Specialists are consumers that primarily eat only one specific organism or a very small amount of organisms. So like this bird here, he only eats this kind of shellfish. Okay, he's a specialist, only wants to eat one particular type of thing. Generalists are consumers that have a varying diet. They'll eat anything really. Then we have our trophic levels. Trophic levels are the nourishment levels in a food chain. So they're the feeding levels. Are they on the lower feeding levels or are they on the higher feeding levels? Those are the trophic levels. Primary consumers are things that are like herbivores. They eat producers. Those are our first level consumers. Then we have our second level, our secondary consumers. They're basically carnivores that eat those herbivores. Then we have tertiary consumers that are carnivores that eat secondary consumers. You can go on and we can have quaternary consumers. Okay. Now, omnivores such as humans that eat both plants and animals may be listed at different trophic levels in different food chains depending on where they are in that ecosystem. I can show you those different levels there. Now, a food web shows a much more complex network of feeding relationships. A food chain is just showing energy flows from this to this to this to this, okay? But a food web actually shows the more complicated feeding relationships in that ecosystem and more complicated ways that the energy actually flows because an organism may have multiple feeding relationships in an ecosystem, okay? So you look at all those different arrows, right? So you can see that there's multiple arrows pointing to different things because one thing doesn't just eat one particular thing. If you look at my shark up here, he's eating the squid, he's eating the fish, he's eating all sorts of different things, okay? So an energy pyramid shows the distribution of energy among trophic levels. And we can use this to compare energy used by producers and other organisms on each trophic level. In between each tier of the energy pyramid, up to 90% of energy is lost to the atmosphere as heat. So as we move up, 90% of energy is lost. So only the original 10% of energy at each tier of our pyramid is transferred from one level to the next. So basically we divide by 10. So if we have 100% of energy down here, we divide it by 10, okay? That brings us, then we're only left with 10% at the secondary level. Divide that by 10, we're left with 1% here. Divide that by 10, we're at 0.1% energy, okay? 90% of energy is lost in the atmosphere as heat. This is a super, super, super common question for them to ask you on your EOC. They might actually give you a number. They might say there's 1,000 kilocalories of energy down here. How many are left at this third level? Well, you need to divide by 10 for each level. So this would be 1,000 divided by 10, which would be 100. 100 divided by 10, which is 10. Okay, so that's how you would end up with what number is here. They might also ask you how much energy is lost. And again, that's 90% is lost to the atmosphere as heat. When we go and do metabolism, we break that food down, okay? Produce energy by eating that food, but we also lose energy by breaking it down as metabolism. A biomass pyramid illustrates an ecosystem's biomass at each level in the distribution of organisms. Biomass is the measurement. It's a measure of the total dry mass of the organism in a given area. So actually like weigh it out. So how much do the producers weigh? How much do the consumers weigh? How much do the tertiary consumers weigh? That's the biomass. And then we also have a pyramid of numbers. Basically, the pyramid of numbers counts up the individual organism at each level in that ecosystem. And so if we count out how many producers we have, that's the pyramid of numbers. How many consumers, primary consumers, how many secondary consumers, and so on do we have at each level? And that's the pyramid of numbers. All right, so that is it for our food chains, food webs, and pyramid models. If you have any questions, please let me know. Thanks, guys.